Note that there is one shortcut to finding out K13, and what is that shortcut? So you know that in the stiffness matrix, all the rows will add up to 0. So what I mean is, you can find out K13 is equal to 0 minus K11 minus K12 minus K14, and where the values of these are given here, like this is K11, K12 and K14. Yeah, so we can actually guess also what should be the value, and then we can also work out and see whether they match it or not. If they match, then you understand that what you are doing is correct, basically. Yeah, so what we see is it will be just negative sign of whatever the value of this plus this plus this is. So if you add them together, so what we get? We will get like this, minus, and then we have K over AB, and then we can have A square over 9, right? So we have A square terms, so A square over 9 plus 1 over 6 minus 1 over 3. So we have 1 over 9 plus 1 over 6 minus 1 over 3. So we have A square and 1 over 9 plus 1 over 6 minus 1 over 3, and same for B as well. So I would say the same value will be added here, 1 minus 1 over 3, 1 minus 1 over 3 plus 1 over 6. Yeah, so we can write like this one probably. So not A square here, we write here A square plus B square. So it will be symmetric to both, basically. Yeah, so so this is what the value is. So the value becomes in this case becomes 9, we have 9, so we have 18 actually. So we will have 18. So let's write here next. So we have K 13 is equal to minus K over AB, so minus K multiplied by A square plus B square over AB, minus K A square plus B square over AB, then 1 over 9 plus 1 over 6 minus 1 over 3. So let's call it 24, not 24 but 18, sorry, we have to get 18. So this is 18 here, and then we have 2 plus 3, 2 plus 3 minus 6, 2 plus 3 minus 6, 2 plus 3 minus 6. Okay, so this is what we have. So we get minus 1. So the value we should get is equal to minus minus. So we have minus minus plus, so K. So we get 1 over 18. So K A square plus B square over 18, maybe K A square plus B square over 18 AB. Okay, so this is what the prediction, this is the prediction. Okay, now we have to see whether we are able to get the same value or not. If same value, then you know that what you have done is correct. It means the values of K11 and K12 are also correct. So let's see. Okay, now N3 we will need. So n3 is, if you look at like this one, so that we derived last time, so 1 2 3 4. So this is 3, so the equation of this and this is the one. Yeah, so this will be simply 1 over AB and x plus a over 2 and multiplied by y plus b over 2. Hence, del n3 over del x will be 1 over AB y plus b over 2, and similarly del n3 del y will be 1 over AB x plus a over 2. Yeah. Okay. Now we can have K13 we can write. So K13 is equal to del, we write like this, right? It's equal to K and del n1 del x del n1 del n3 del x plus del n1 del y del n3 del y and d omega, or equal to omega. We have k and we can write k del n1 del x del n3 del x d omega plus omega k del n1 del y del n3 like this is equal to, you can write as k omega and del n1 del x, so we can write k over a square b square, and del n1 over del x is nothing but 1 over AB, and then n1 has x the y minus, so we get here y minus b over 2, and the n3 term will have y plus b over 2. So both are opposite, so one will be plus, one will be minus, that's it, that's the only difference. So d omega, similarly here, plus k over a square b square and omega, and here x minus a over 2 x plus b over 2 d omega. So whatever the value we get, we just repeat it for that, so we get that. So equal to k over a square b square, and then we get for this, so a square y square minus, so let's write like this, so omega y square minus b square over 4 d omega plus k over a square b square omega x square minus a square over 4 d omega. Okay, next we can write is equal to k over a square b square. Okay, and then we have y cube over 3 minus b square, so this has just y. Okay, so we can expand it here, so we can say here minus a over 2 to a over 2. Yeah, so this is for x basically. Yeah, so Okay, so we earlier I have not really basically thought about the order of the in the limits, so but I assume that you understand that if you are saying minus a over 2 to a over 2, that applies to dx. If I am saying it is from minus b over 2 to b over 2, it applies to y, or when it is dy, like that. So basically this one, the first one, has only y, so we can write that as dx, and then we have minus b over 2 to b over 2, and then we have y square minus b square over 4 dy plus k over a square times b square, and here you will minus b over 2 to b over 2 dy, and then minus a over 2 to a over 2, and here we will have x square minus a square over 4 dx. Yeah, so that will be equal to so this is a, so ka over, so we write ka over a square times b square, and then this one, and this is y cube over 3 minus b square y over 4 b over 2 minus b over 2. Okay, and similarly here we will have plus kb over a square b square and x cube over 3 minus a square x over 4 a over 2 minus a over 2 is equal to, put the value here. So we know that this is odd function, both of them, so we can write simply 2ka over a square times b square, and here we will have b cube over 8 times 3 24 minus b cube over 8 set plus kb over a square times b square. Here also we have 2, and a cube over 24 minus b cube, sorry, a cube only, so a cube over 8. Okay, will be equal to, so here we can have like 3 here multiply, so 2 1 minus 3, so you get minus 2 b cube over 24. Yeah, so what do we get? We get minus 2 over 24, so minus 12, and 2 is here also, so minus 1 over 6, right? So we get minus 1 over 6, so minus 1 over 6, yeah, times k is here common, so we write a k, a and b we are taking out from up and down both, so we have k over ab only. Yeah, and then minus 1 over 6 we have writing here, and what remains now is a square plus b square. So this is what we are getting. So if we see what we calculated, we said 18 here, so there is something wrong that we have to see. So how to check what is the correct value of K13, whether this is the one which is correct one or the one we actually found out. So which is like this one. Okay, since we have found out K13 from scratch, so we can assume that this is correct. Now let's see what happened here. So it says here we have derived this one, but we have to assume that all others are correct. So let's look at whether some problem still has some problem with these values. So if we see the value of, say, okay, so let's look at K12, okay, and then we have, okay, so we start here K11, which is like this one, and then K12 we have calculated first, and the value K12 is given like this one, K11 is here, and the final value we are saying K over AB divided by 3, and oh, okay, so here we are writing 9, actually it should have been 3, see here. Okay, so we made mistake here, so this should be 3, not 9. Yeah, so since this is 3 here, so we have 3 here. Okay, so given 3 here, now our values accordingly will change now. So if you see here, we will have 1 over 3, 1 over 3, so we write 1 over 3 here, so 1 over 3 here, right. So 1 over 3 plus 1 over 6 minus 1 over 3, right. So 1 over 3 and 1 over 3 cancels out, we have 1 over 6 with minus sign. So value what we should get is not this one, basically we have 3 here, 3 here, so if we have 18 in common, so we should write 6 here, so actually we should have 6 here. Yeah, so instead of having 18, actually we should have 6 over 8, 3 over 18, so our value should be basically 3 divided by 18, so 1 over 6. So value should have been equal to K A square plus B square divided by 6 AB. So this is the correct answer, K A square plus B square over 6 AB. So our prediction should have been this one. And what we are getting is, if we look here, minus 1 over 6 K A square plus B square over AB. We have the minus sign here too, and here also we have, so okay, we have 6 plus 6 minus 3 here, minus sign, so we should get minus term here, so we should have minus value here. Okay, so minus K A square plus B square divided by 6 AB is the also predicted one, basically, if you look, yeah, although we made some mistake, and we are here also we are getting minus 1 over 6 K over AB A square plus B square, and this we know that this value is K11, so we write K13, sorry, K13, you know that this will be equal to K31 will be K24 equal to K42. Okay, so for us this is ready now. So all the K's value we have, so we can construct the K now, big K. Yeah, so big K will be equal to we have small k over a square ab basically, and then we have like this, we can write it like this. Okay, so the first one is k a square plus b square over 3. Second one is k12. So we have k12 here, so k over ab, so this is we have common, then a square over 6 minus b square over 3, 6 3. So a square over 6 minus b square over 3. Okay, third one, so this is k11, k12, k13 we found out just now. So we have here, yeah, so k minus a square plus b square over 6ab, so minus a square plus b square 6. Okay, so 6 ab is here. Okay, then so we have together this one 1 4. So 1 3 1 4. Okay, so we have 1 4 here. So this will be just is replacing a with b, b with a. So we'll have a, so basically b square over 6 minus a square over 3. Okay, so we have that, and then we can make it symmetric. So we will have a square minus a square over 6 over b square over 3 minus a square plus b square over 6 b square over 6 minus a square over 3. Done. Then next is 2 2. So okay, so a 2 2 will be, so let's write different color now. So a 2 2 will be the same value here, so this will be a square plus b square over 3 this will have here the same value, this is also the same value. Okay, then we have 2 3. So this one is 2 3, then 2 4. So 2 3, let's look at it. Also we can figure out from the picture also. So let's what is the meaning of 2 3. So see here, 1 2 3 4. Okay, so 1 1 is same as 2 2, as 3 3 and 4 4. Now this one is 2 3, means from here to here, so which will be equal to 1 4 basically. So whatever is 1 4 we can get it, right? So 2 3 is equal to 1 4 only, so 1 4 is this one, so we can write simply this value here. So we get b square over 6 minus a square over 3, and then 2 3 done, then 2 4. So 2 2 2 1 2 1 will be equal to this, 2 2 equal to this one, 2 3 is equal to 1 4 only, 2 4 will be equal to 1 3 only. Yeah, so 2 4 will be equal to 1 3. So this value will go here. Simply we can have minus a square plus b square over 6. So what we are seeing is the same values rows in the second values in the or entries in the second row is similar to in the first row, but this is rearranged. So this we are seeing here, this value a square minus b square. So this one, this value we are looking at here. Okay, so this one coming from here, this one coming from here, this one coming from here, this one coming from here. Yeah. Okay, and same thing will be the, since this is symmetric, so this value will go here also. So we write here b square over 6 minus a square over 3, then minus a square plus b square over 6. Okay. Now here we will have the same value as this one, so we will use different color, but we write the same thing. So here also we have a square plus b square over 3. You can see here also which one is remaining, you can immediately you can see. So this value is coming from here, this value coming from here, this value coming from here, this value should come from here. So this should be this one here. Okay. Why? Because all add up to 0. So we have this one. So we have need some term which will add up to 0. Hence this is the one which is remaining. So hence because of that. Or you can also think in terms of this. This is 3, third one. This is the fourth one, 3 4. So this 3 4 is equal to 1 2 only. Right? So 3 4 is equal to 1 2. So 1 2 is this. So 1 2 is same as this one. So same as this one. So we write here a square over 6 minus b square over 3. Similarly, we write here a square over 6 minus b square over 3. Okay, and at the end we have this, the values in diagonal are same. So we have here a square plus b square over 3. So we got the stiffness matrix for the 4 noded. So this is for 4 noded quadrilateral element, or not quadrilateral exactly, but is quadrilateral only, but is not for general purpose, but this is for rectangular element. Okay. So this is how you can derive the stiffness matrix for 4 noded rectangular element. Now that we know how to derive the stiffness matrix for a 4 noded rectangular element, we can now equate A equal to B for a square element, right? So basically A here we will put B equal to A, and we can find out for the square element. So a square element. Okay, so 4 noded. We will put B equal to A, and we will find out according to that, right? So for a square element, we will have like this, from here to here, here to here, here to here, here to here, all same A here, like this. So the value we can see here, we have a K here, then a square, and then here also we will have a square term, right, a square plus a square. So a square here and a square here. So we will see that those terms will, the a value will not be there. Yeah, so we had ab here, so a square, then a square plus a square, so it's gone. So that means we just have put k, and it will not depend on the dimension of a. So we write k, then you have a small k, and then we have 1 2 3 4. Yeah, so like this one. We can put the values. So ab, so a square is automatically we have, so we can just remove value of a b and just assume a square equal to 1, b square equal to 1, and we are fine. So we get 1 plus 1 over 3, so it becomes 2 over 3. So we write here 2 over 3. Here a square, 1 over 6 minus 1 over 3, so 2, 2, so minus 1 over 6. Here again minus 1 plus 1 over 6, so 2 over 6, so minus 1 over 3. So minus 1 over 3. Last one we have 1 over 6 minus 1 over 3, the same value as this one. So we have minus 1 over 6. Okay. Okay. And similarly we can write all the other value, like, so we can 1 over 6 is here, minus 1 over 3 is here, minus 1 over 6 is here. Yeah, so we will have 2 over 3 here, then 2 over 3 here, and 2 over 3 here. Done. Okay, now value here. So we have seen that this value goes here, this here, similarly this will go here, this will go here. So we had seen earlier, so 1 over 6 here, minus 1 over 3 here, and minus 1 over 6 here, minus 1 over 3 here. Okay, so here also minus 1 over 3, 1 minus 6, so minus 1 over 6 2 times, we have just 1, so minus 1 over 6 will be here, so we write minus 1 over 6 minus 1 over 6. Okay, so done. So this is how these four square matrix. So next is we can simplify this further actually. So we can have this 6 taken out. So we will have k over 6 here, and then we can write here all. So it will be 4 minus 1 minus 2 minus 1 and so on. Yeah, so we can also write the simplified one. So that big K is equal to a small k over 6. Okay, and then just write multiplied by 2, so becomes 4 minus 1 minus 2 minus 1. So 4 minus 1 minus 1 minus 2 minus 1 minus 1 minus 2 minus 1. So we have 4 minus 1 minus 2 minus 1 minus 2 4 minus 1 minus 1. So this is what for a square matrix. Yeah, this is for the square matrix. Now that we are able to find out the stiffness matrix, the next thing is how to find out the force vector. Okay. So force vector is like we have found out K, and then we will have the temperature, the vector, and there will be a force vector here, and this force will have two kinds of thing. Also we have derived and we found out that we are going to have two things here. So one is coming from the S part, so we have S dn, so whatever the value is coming. So this F is coming from the two part. First part is based on the body force, we call it S, and then we have N, right. So S like times W d omega we did, right. So but W has W1, W2 all things. If you get rid of that, then what you will find is F. So you say F Bi will be equal to Ni S d omega. Means the ith shape function you multiply with the source and you integrate, and this is because of the body force. So this is because of the body force. Second is a body force. Second is coming from the boundary, and that values we have seen that was like this one. We had q dot, so we had q bar, basically we had q bar. Yeah, so we wrote it like q bar, and this was on the boundary. So here gamma. Yeah, so we had q bar, and then we have had W part there, q bar times W, yeah, times W and d gamma, meaning that the, and we had the minus sign here. Okay, and this we called it F, you can say F gamma, F gamma you can say, or basically this is because of the boundary forces applied, means the flux applied, and hence you can write this as, this is minus because q bar is the heat loss, hence U minus. So the force has the force that the energy if you are gaining, then F is positive. Yeah, so remember, positive if heat gain. So F gamma I is given by Ni, yeah, and then you have q bar at the boundary and integrated over the whole gamma. Okay, so basically the, now depending on the problem that you have to apply these things. Okay, so let's say assume, so there may be problem something like this one. So this is very problem specific. We will take some very small example. Let's say we have one square, yeah, so square element, say this is 1 2 3 4. We have calculated the stiffness matrix already, and we can now, we have to solve this one. And solve how? We can say that t is here given is t equal to 0 is given here. We can say that. We can say that here on this one only on this one the value q is given, q bar, and q bar is equal to say 5 given, means there is a heat loss of 5. Okay, so say q bar equal to q naught, let's call like this one. Here we can say this part is okay. Maybe there is no heat loss or gain at this place. We can also say here q bar equal to 0 and q bar equal to 0. Now we have to solve it. How will we solve? There may be a s equal to s naught, which is constant, which is also given here, which is for the whole one. Then how to find out? The stiffness matrix that we have calculated for this, so we can use straight away this one. K is given, the small k is given, you can straight away use it. Now only thing remains is like how will you find out the forces and all? So T for us will be T1, but T1 you know that T equal to 0. Yeah, so T1 will be equal to 0. So because it says the whole from here to here the temperature is 0, and hence T1 equal to 0, T4 equal to 0. So you can write T1 equal to 0, then we don't know what T2 is, we don't know what T3 is, and T4 is also equal to 0. So this is our temperature matrix, temperature vector or displacement vector. Okay, now the force we have to find out. So now this is a force, or this is a body force which is given here, and these have to be, finally you know that all the calculations are done on these nodes only. So although S is distributed, this load heat gain is distributed everywhere, it is like this one finally, but we have to put this total value to on these nodes only. Yeah, and you can do like if you are experienced, or if you have insight into it, you automatically know that in this case from body source total will be S times area, or area is equal to A square. So let's say A is the side of this square, so S times A is the total, and hence it will be 1/4 everywhere. So automatically it should go like 1/4 everywhere, and you know that from body source only FB will be equal to SA square over 4 1 1 1 1. So you will get like this one. This one just from the inside, what is the meaning of that? This actually the total heat generated is S times A square and divided by 4 goes each of them. So it will be like this one, or you can use the equation. And what is the equation? Equation is let us say this is equal to F B1 F B, let's call it Fs1, okay, because S is there. So Fs1 Fs2 Fs3 Fs4 goes like this one. So Fsi will be equal to omega, and then we have Ni, yeah, Ni, and then S d omega. Or for example here one was, you remember one was 1 to this one, S we are taking as constant, N1 was 1 over AB, and we had x minus A over 2, y minus B over 2 d omega, and which will be equal to nothing but so yeah, S naught over AB, and then we have this one, so we get x square over 2 minus ax over 2 minus a over 2 multiplied by, similarly here, y square over 2 minus by over 2, yeah, minus a over 2, sorry, this will be b over 2 and b over 2. And what do you get? Here you get, if you put minus value, this will not work, only this will be 0. So only this one, so we have minus, then a, and then you have, sorry, one thing, this has to be plus, minus to plus, right? So yeah, okay. So what do we get? We get simply here in this case a over 2 multiplied by a over a, so minus a square by 2. Here you get minus b square over 2. Yeah, so we get simply you are getting a square times b square over 4, but ab you have, so s naught ab over 4. So basically what you get is s naught ab over 4, or will be equal to s naught a square over 4, assuming a equal to b. Yeah, so you saw you got this value only, and there is an insight why it should be like this one. So this is how you calculate the force. So S naught, if you have, then you get S naught a square like this one. This you got because of the body force. Now next thing is there will be also, because of the heat is also coming or being transferred through the boundary. So in this example, these two surfaces are coated. Basically coated means there is no heat transfer from these two sides. Yeah, and here temperature is there, so there will be some value coming here. So but anyway we have to calculate that. But here it's given that there is a definitely there is a heat loss. That means we have to count that. And here we don't know because it says T equal to 0, and here it's Q equal to 0, or simply it says Q bar equal to 0 here. This is Q bar equal to 0. Here is Q bar equal to Q naught. Now if you look at the mathematical formulation for this one, it says this term here is based on Q times Q naught or Q bar times this, and because of this boundary, so this is the boundary. So we come this gamma we get because of the divergence. We apply divergence theorem and we get that. So this and then d for the whole boundary. So that means we have to go through the boundary only. Now W has is terms of N1 W1 plus N2 W2 and so on. So finally N will appear here. And how will it appear? So basically if you want N1, let's say in this case, will there be a value of Q1? So what I'm saying is there will be a Q gamma, not Q gamma, say force due to gamma terms as well. Let's you call it F gamma 1, F gamma 2, F gamma 3 and F gamma 4. There are 4 nodes and there will be 4, just like we had 4 for the source as well, for each node. Okay, now if you apply just intuition, yeah, so then you know that since all the heat is being transferred from here, so this will have effect on this only, should not get any effect here. This also true if you think that the value of F mathematically, this value will be nothing but F gamma I is equal to this Q bar and Ni d gamma. Okay, like this one. Okay, this we have derived earlier actually. So yeah, so we get like this one. So if this is the one derived like this one, let's say in the example we are taking, if we are taking n1, then what happens? N1 is non-zero here. N1 is equal to, actually this is 0 here also and here also. So N1 is 0 from here to here on this line, also 0 from this line. Since we are calculating for q bar equal to q naught, for because of this only, all others it's 0, so we don't care. So only q naught is given at here only. So that means this gamma will be, we are talking about this one only, this gamma only. Yeah. So basically this will be equal to q bar at, so let's say if you call it, this one is gamma 1, gamma 2, or let's call surface 1, surface 2 probably. Yeah. Okay. Okay, let's call surface 1, this is surface 2, or boundary 1, boundary, so maybe boundary 1, boundary 2. So boundary 1 B1, B2, B3, B4 and B4 boundary. So basically this Q will be defined as this boundary 2 only. Yeah, so basically for all others we don't have to take care. Here we don't have to take care because t is given, so other we don't know, so we are not going to calculate. There is no, we are not bothered about what is the, because we don't know the value of this, right? Here we know, so but this will be equal to boundary 1, yeah, plus boundary 2 plus boundary 3 only, right? Ni d gamma. But what we see at other boundaries, this q bar is equal to 0 in this one and q naught is here, so we can say is equal to boundary number 2 and this becomes q naught in ID. Okay, so q bar is 0 here, 0 here, q bar equal to q naught, so we write q naught, all others becomes 0, only we have boundary 2 is here and we have like this. Now this Ni is like this one. If you put N1, so if you find out f gamma 1 A1, so will be q naught N1, but N1 is 0 at boundary 2. N1 is 0 here because N1 is 1 here and 0 here. So f gamma 1 will be 0, so will be N1 equal to 0 at B2, will be 0 simply. And similarly for N4 as well, because this is here, so the value of N is 0 here and here both. So here definitely 0. So this is also equal to f gamma 4. Okay. Now what else? For this case, now it that really means only this whole thing is going to shared between this node and this node only, because at this and this it is 0, this and this only. How it will be shared? So now you think in terms of 1D element, and if you had a 1D element and if there was a body force like this one, what half of this goes here, half of it goes this here. So total which is moving out of here will be what? Q naught times the value of this will be A. So this one will be given by, if Q bar will be defined as this joule per unit second per unit area, right? So area here is 1 is the depth, the section depth here, so 1 times A is like this one. So you have Q naught times A is the total heat which is escaping. So half of that will go here, half of that go here, and of course with the minus sign, remember, right? So we will have a minus sign because whenever we have the force here is the heat coming to the system. Since here this is the Q bar is losing, so hence you will have this value. Okay, so that means from just my intuition, you can if you by insight you can write here simply by insight F gamma 2 will be equal to Q naught A divided by 2, which is equal to F gamma 3. You can write like that, or you can use the equation to also find out. And how will you find out? Okay, so F, let us say find out F gamma 2 will be equal to minus, and then this is along this only, remember. So this will be here, this will be at this point. So what is the value of N1, and we are going from here to here, we are integrating over this only. Either you can use a new the interpolation function, or the shape function just for boundary, just for interpolation on the boundary, like linearly varying from 1 to 0 here, this will be 1, second will be 1 to 0 here, and then you can use 1 and 2 to actually get integrate over this one. Either you can do this one, or you know the behavior of this one. Which one? The shape function that we use here. So the N2 or N3, okay, N1. So like N2 we used which was equal to minus, so we have minus 1 over AB, and then we had x plus x plus AB, x plus A over 2 multiplied by y minus B over 2, right? Okay, omega, and multiplied by q bar and d omega. So this is N2, this is 2, so this is N2. Okay, so N2 is here, so this equation is y equal to x equal to minus A over 2. So we have x plus A over 2 here, and this one is y equal to B over 2. So we have here, and we have minus sign here, so that the value is 1 here, multiplied by Q naught. Now if you see this, you will realize that we are talking about, in this case, sorry, this will not be here, but this will be B2 only. Yeah? So we are going to this will be integrated over B2 only, because all other places is 0, this Q bar is 0, so Q naught, so at the B2 only. Okay, now B2 is the boundary number 2, this is the surface basically, and here what we see is y is varying from minus b over 2 to b over 2, and x is equal to a over 2. So this is fixed. So we can note it down. So what we see is x is varying, x is constant, x equal to a over 2 simply, and y is varying minus b over 2 to b over 2. So if you, that really means this value x is equal to a over 2, so you write a over 2, so you get just a here, and then rest is this one. Yeah, so rest is this, and the whole thing we can then write it as f gamma 2 is equal to minus, and then just x is, just y is varying now, so we write minus b over 2 to b over 2. So this is how it is going this way. Okay, so minus 1 over ab minus 1 over ab, and then we have a. Okay, so since we have added for the whole thing over the b2 we have a over 2, so we have a, then y minus b over 2 varying, so y minus b over 2 which is varying dy, and this is going from here to, and then then we will have q naught here, and then dy. Done. Okay, and now we can see now what is the value of that. So we can see here now equal to this minus plus, so 1 over ab, a also is here, so a over ab minus plus, so these things gone, q naught we can also have q naught, and then we have integration of this only, so we have y square over 2 minus by over 2 b over 2 minus b over 2. Okay, get a q naught, or simply we write q naught over b, and then this cancels out, so we have minus b square over 2, so minus b square over 2, or simply we get minus q naught b over 2. Okay, now for a square one we know that for a square one a equal to b, yeah, and or b equal to a, hence f gamma 2 equal to minus q naught a over 2, and that's what we also we had guessed, just calculated, we had guessed should be like this, means half, you are getting the half of that. This is what we have got. So, and hence the half should go to the other one, and hence similarly we can also find out f gamma 3 will be equal to minus q naught a over 2. Yeah, so that means f vector for this example will be equal to f because of the source plus f because of the boundary, and which is equal to just a square. We are taking the example of that, say square will be equal for the square element, this will be equal to simply the s naught a square over 4, and then we have 1 1 1 1, then plus plus we have, sorry, we will have minus, or we can write like this one, plus q naught a over 2, 0, minus 1, minus 1, 0. Yeah, okay. This is how the force will be calculated. Also, the where it is fixed, there will be a reaction forces as well. So, you know, where the fix is the t equal to 0. So, here and here there will be reaction forces, means there will be some energy which is coming or going at this one. Yeah, okay, at this node, not here, but at node it will be because of the effect, because of this one. So, we can write R1 and R2. So, plus reaction we have to add. So, plus reaction we can say R1 0 0 R4. So, this is what the force vector will, you can calculate like this one. So, the idea is once you have the force vector like this one, you know, so here you have you can find out if you have value of S naught, a value this one. So, you will see that if total will be the row number 2 and 3 which will have numerical value, and you know that k times your equation is k times u. So, you have k times t equal to f, where k is given like this for the square matrix, multiply with t, where t1, t2, t3, t4, where t1 is equal to 0, t4 equal to 0. You have to find out what is t2, what is t3, and here you will have f, where you have some value plus r1 here, then there is some numerical value, then some value plus r4 here. So, that means you can invert, you can find out T2 and T3. Once you have find out that, then you can find out other quantities. So, this is how you do in 2 dimensions. So, we have seen how to calculate the stiffness matrix and also how to calculate the force vector as well. Okay, so through the examples only for the we have found out, and we have used the rectangular element and a square element to demonstrate that. Okay, so that is all for now.